The sample code started out with classic C-style arrays, C++ raw arrays of car stars representing animals and of integers representing some numbers. And these are fixed size arrays. As you can see when I hover, array size is 5. I'd like to replace these with vectors. The performance is going to be about the same. I'll have a little more flexibility so that if the code puts too many elements into the vector or doesn't put enough elements into the vector, we're less likely to run into errors. We'll also gain some nice flexibility in terms of working with those collections in a variety of different ways other than just going through in these language for loops. So first thing I need to do is include vector. And a using statement so that I don't have to type the full name all the time. So I could do this, vector of string, animals, and what I'd love to be able to do is this that you see right here. This is initializing a collection just as easily as you initialize a raw array. And I can't do that in this version of Visual Studio. So that capability, it's called uniform initializer syntax, is in C++ 11, but hasn't quite yet made it into this version of the compiler. So instead, I'm going to do it a little slower way. Going to declare myself a vector of strings called animals. By the way, one of the things that happens when people are doing a lot of this is they may accidentally set this mistake in motion. This mistake, as I may have mentioned before, is actually declaring a function called animals that doesn't take any parameters and returns a vector of string. When you then try to work with it, it's like, why are you trying to work with a function as though it were an object? So be aware of that. Don't put those brackets there. If I do know that the vector is going to be a certain size, in this case array size, I can use the reserve method to ensure that we don't repeatedly say, oh, I pushed one in, now I'm putting the second one in, oh gee, not big enough, let's expand it and copy everybody. If I already know I'm about to put 5 elements in, I can just do that. Now, because we don't have the uniform initializer syntax, the next few lines are kind of awkward. But remember that in real life, you would almost never set up a vector and immediately push 5 or 6 hard-coded strings onto it. You would be going through some process, accumulating these and building them up in a vector. It just looks awkward as a demo. The way that I'm going to get entries in, animals.pushback at zebra. And I'll just copy that. Now I've pushed all my strings onto the vector. The code that's already here isn't broken. You can work with a vector of strings just exactly as if it was a raw array of strings using this notation to index into the vector. And for now, I'm going to leave this code alone. When you try to modernize existing code, it's a little bit like when you're trying to tidy up a really messy room. Things are shoved into drawers any old how, and you kind of pull them out of the drawer and spread them out into piles, and then half of it goes to the dump. At the peak of it, it looks worse than when you started. And that's kind of where we are here. We've gone to this trouble to make a vector, but then we're still talking to it just as though it was an array. We've gone to this trouble to use strings, but we're still talking to them as though they were arrays of characters. Trust me, this code will get neater and smoother as we continue through the process. For now, it's important that it's still workable and that it still builds. Let's get our array of numbers into being a vector of numbers. Again, I'm going to reserve array size just to save the resizing on every time, and then I'm going to push back these different values. And absolutely, I would prefer to be able to use the uniform initializer approach. That day is coming. As with the other array that has become a vector, we can continue to access it this way. That works just fine. Let's just confirm it still builds. It does, and we'll run it. You can see the strings are still successfully concatenated together. Here we print out all the numbers. Here we print out all the strings. Great.